Let's talk about insertion sort. So insertion sort is a little bit easy to understand. So whatever you're sorting, and on the left side is always sorted. So you will pick a value when you want to traverse, and if the value is already less than the current value, imagine 29 instead of 37. 37 is greater than 29, so you don't have to go over on your left. So they just run the visualization, and then you'll be able to see what happened faster. So 29, 10, and 5, and then 29, and again. And 37 and 29 is already sorted, so you don't have to move again. And there we go. So 29 and 10, you'll compare, and then this will be the sorted sorting array, right? So let's back to the sorting. So using the same array, and then this is putting the before sorting, and this is insertion sort, and this is after sort. So back here, so let's just delete the code over here, and I will probably just take out this array. Maybe show you the diagram. I mean, show you the step. So whatever I do, I start from I equal to 1. I less than array.length I plus. So one more second. Okay, so here we go. So imagine this is the array, right? And then I will have to pick the arbitrary j, and j will always less than I. Okay, j will always less than I by 1. And also another value, which is key, is actually your current I itself. So which is I. I mean, I is right here, right? And this is j. I and j is right here, right? If I is less than j, and this is actually represent key. So let me just replace to k, and you have to swap. You have to swap j and k. So this is not actually swap. You're replacing. I mean, replace 29 on this spot. And since we already memorized the key for array I, right? At the end, we just have to place it over, right? So if j is greater or equal to 0, we traversing based on j, okay? In the inner for loop, and also if the array j is less than, actually the key, sorry, let me just do like this. Key is less than array j. If this is making sense, like in this example, 10 and 29, I will have to assign array j plus 1 equal to array j. Okay, did we get it? 29, actually j index plus 1, this will be this index. I will assign 29 to this index, and I will decrement the j. It doesn't matter it goes below 0, because at the end, I will assign j plus 1 to the key. And let me just show you the diagram. My diagram first. So I will swap 10 and 29. I mean 29, 5, 37, and 14, right? And I will break out the while loop because j is less than 0 anymore, right? So j plus 1, negative 1 plus 1, which is 0. Then you'll have 10, 29, and your remaining 5, 37, 14. And again, I will move my I on the next integer, which is 5, right? And j will automatically go with I, which is k. And 5, I will check is 5 is less than array j, right? This is true, right? 29 and 5, right? If this is less than, I will have to assign. So let me just copy. So I will assign 10, 29. I will assign 29 here, 37, and 14. And I will decrement my j. doesn't matter for the k. So j is still greater or equal to 0, and I will keep comparing phi and current j. So if that is true, so phi is less than array j, right? I will have to assign 10 to j plus 1, right? J plus 1 equals and 29, 37, 14, right? And I will decrement my j, and I will break out the while loop. Then I will assign 5 at this point, right? J plus 1, q was 5, right? 10, 37, and 40. And this will be the solution. So whatever you understand, let's just run it. And this is a sorting, right? Yeah, using insertion sort. So let's look about the insertion sort time complexity. So let me just find it. So the worst case n square, which is true, you traverse two inner for loop. And the average is n squared as well. The best case, all of them. For every single time you want to compare, it's already sorted, so you break out the value, right? And the space is constant. You are not allocating any space, right? And the stable is true, which is yes. You will know if you have a duplicate number. If you have 5 right here, right? The first 5 is always before the second 5, so it doesn't matter, like, which is not equal sign, right? So you know, like, this will be allowed. And method is insertion, so every time you want to swap or what, you actually insert to the front if that is allowed, right? So 29, 10, right? You turn to the front the insertion method, and I cannot tell you any more sorting algorithm. Hope you understand, and I will see you next time. Bye.